Welcome to The Explainer. Today we are going to get into a topic that can be a little tricky when you're starting out with Docker, and that is networking. We're going to unpack exactly how these containers, which are built to be totally separate, can somehow talk to each other, and, the rest of the internet.
So, this is really the central puzzle we're going to solve, right? How can a container be this perfectly sealed, isolated environment, but also be a fully connected part of a network? It sounds like a total contradiction. But don't worry, we're going to break it all down. Okay, let's dive in.
So before we can even talk about connecting containers, we first have to get our heads around how they're kept separate. And the secret sauce here isn't actually something Docker invented, it's a really powerful feature that's built right into the Linux kernel itself.
Every time a container spins up, it gets its own private network namespace. You can think of this like its own little digital island with its own set of network rules, totally cut off from the host machine and all the other containers. This is amazing for security and isolation, but it's not very useful for an app that actually needs to talk to anything. So, how do we build a bridge off this island?
Well, that's where this thing called a virtual Ethernet pair comes in. The best way to think about it is as a digital patch cable. Docker creates one of these for each container. It plugs one end into the container's private island, which the container sees as its ETH0 network card, and it plugs the other end into the host machine. And just like that, we have our first physical link out of that isolated box.
Okay, so now every container has a virtual cable connecting it back to the host computer, but we still need a way for them to talk to each other. This is where Docker's bridge networks come into play. Let's see how this all gets wired up.
Now, way back in the early days of Docker, we used something called the -link flag. It kind of worked by messing with the hosts file inside the container, but honestly, it was really rigid and clumsy. If a container restarted and got a new IP address, the link would just break. So yeah, it's considered legacy now, and for good reason. We have a much better way to do this.
And this is a really key point. You need to understand the difference between the default bridge network that Docker gives you and the user-defined networks that you create yourself. The default one is, well, it's a bit of a free-for-all. No automatic name resolution. But when you create your own user-defined network, you get much better isolation and, this is the real game changer, automatic service discovery. Containers can find each other just by using their names.
So that's the thing. Containers on one of these user-defined networks can talk to each other, but we all know their IP addresses can change anytime they restart. So how do they reliably find each other just by using a simple name, like database or API? How does that work?
The answer isn't some complicated configuration file that you have to maintain. It's actually a super clever bit of networking magic that's built right into the Docker engine. And it all comes down to one very specific, very special IP address.
Check this out. Inside every container that's running on a user-defined network, the DNS resolver is pointed to this IP address, 127.0.0.11. Now, this isn't a real server you can ping or connect to on the network. Think of it more as a secret phone number that only Docker understands.
So what happens is, that special IP address gets intercepted by the Docker daemon itself. It's running its own tiny embedded DNS server that knows all about the other containers running on that same network. Let's take a look at the logic it uses, because it's actually pretty simple.
It's a really elegant two-step process. First, Docker checks if the name you're asking for, let's say Postgres, matches another container on that same network. If it does, boom, it just hands back that container's internal IP address. If it doesn't recognize the name, it just forwards the request on to your normal DNS server to find things out on the public internet, like google.com. It's simple, powerful, and it just works.
All right, so we've got our containers talking to each other. That's a huge step. But now we need to open the main gates and let traffic come in from the outside world so that, people can actually use our applications.
And we do this using the P flag, which creates a port mapping. All you're doing is telling Docker, hey, any traffic that comes into my computer on this specific host port, please forward it over to this specific port inside my container. But for security, it is absolutely crucial that you're careful about how you expose those ports.
So by default, when you map a port, it binds to 0.0.0.0, which basically means it's listening on all network interfaces. This makes your service available to your entire network, which is exactly what you want for, say, a public web server. But if you're running something like a database that should only be accessed locally, you should bind it specifically to 127.0.0.1 or localhost. That keeps it safely off the public network, accessible only from the host machine itself.
Okay, this right here is the #1 gotcha for beginners. It trips up almost everyone. Docker forwards traffic to the container.
But if your application code inside that container, your Python app, your Node app, whatever, is only configured to listen on its own local host, it will never see that traffic. It's like it has earmuffs on. Your application code must be configured to listen on all interfaces, which is 0.0.0.0.
So what happens when you've set all this up, you've mapped your ports, you think everything is perfect, and you still get that dreaded connection refused error in your browser? Ugh! Let's quickly run through how to figure out what's wrong.
9 times out of 10, I promise you, it's one of these 3 things. Number 1, the application process inside your container simply crashed. Number 2, it's listening on the wrong interface, that localhost problem we just talked about. Or number 3, it's just a simple typo in your port mapping. You forwarded traffic to the wrong port.
So here's your simple, effective checklist to diagnose the problem every time. First, run Docker PS. Is the container actually running? Second, check the logs with Docker logs. Are there any obvious startup errors? Third, shell into the container and use a tool like Netstat to see what your app is actually listening on. And finally, from inside that container, try to connect to the app itself. If you're systematic about it, you'll find the problem fast.
And really, once you master these fundamentals, namespaces for isolation, bridges for connection, DNS for discovery, and port mapping for access, you've got the foundation for building some seriously complex, multi-container applications. And from here, you can start exploring really powerful tools like Kubernetes. So now you know how to wire it all up. What are you going to build next?